All right, so today we're going to talk about the quadratic formula, which is another way to solve a quadratic equation when you can't factor. You can use it to solve an equation when you can factor as well, but the quadratic formula will always work regardless of whether or not the equation is factorable. So, let's remember what the quadratic formula is. Okay, so when you have ax squared plus bx plus c equals 0, where a is not equal to 0, you can use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you plug in your a, b, and c into the quadratic formula, and that will give you your x values when the equation is equal to 0, which basically gives you the roots or the x-intercepts or the solutions to that equation. Okay, so let's try it for example number 1. Our a value is 1. Our b value is negative 5. And our c value is negative 14. So now it's just a matter of plugging those values into our quadratic formula. So x equals negative 5 plus or minus the square root of negative 5 squared, that's a 5, minus 4 times 1 times negative 14 all over 2 times 1. And now it's just a matter of simplifying. So x equals 5 plus or minus, that becomes 25, plus 56 all over 2, which becomes, excuse me, 5 plus or minus the square root of 81, and then all over 2. So then that becomes 5 plus or minus 9 all over 2, which equals, well, let's do it this way. So then you have 5 plus 9 over 2, which is 14 over 2, which is 7. And then you also have 5 minus 9 over 2, which is negative 4 over 2, which is negative 2. So our answers are x equals negative 7 or 2. So those are the two answers. Now, because you get two whole numbers as answers, that problem could have been factored. You could also complete the square. You could do this in several different ways. You could even do graphing for this one. Because you get the whole numbers, it will be easy to see what that value would be. Okay? So let's take a look at example number 2. Now we have a different a value. We have a leading coefficient. So our a value is 5, our b value is 4, and our c value is negative 2. Okay, remember that the a always goes with the x squared, the b always goes with the x, and the c is always the constant. And then it's just a matter of plugging it into the formula. So we have x equals negative b, so negative 4, plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 5, times c, which is negative 2. And then all over 2 times a. All right, now we just need to simplify. So we have negative 4 plus or minus the square root, and that becomes 16, plus 40 all over 10. So then that becomes, let's roll that up a little so we can see it better. All right, so that becomes negative 4 plus or minus the square root of 56 all over 10. And then we can break down that square root of 56, and we can make that becomes 4 times 14, so square root of 4 becomes 2, and we still have that 14 inside. That becomes a 10. So then that can simplify. You can divide each of these by 2. So that becomes a 2, that becomes a 1, and that becomes a 5. So we get negative 2 plus or minus. You can write the 1. You don't have to. It doesn't really matter. Square root of 14 all over 5. So our answers, remember that we have 2 answers. Our answers are x equals negative 2 plus the square root of 14 all over 5, or negative 2 minus the square root of 14 all over 5. Again, whenever you have an x squared, you're going to have 2 answers. The highest exponent tells you how many answers you're going to have. And you'll notice that these are irrational answers. So this problem would not have been factorable. You could have completed the square. If you tried looking at the graph, you wouldn't have been able to tell exactly what the answer would be. You would get a decimal. So for a problem like this, you'll want to use quadratic formula or completing the square. And really with the a value being 5, it'll be easier to use quadratic formula than it will be to complete the square, because you'll have to divide everything by 5 if you want to complete the square, and then you have a lot of fractions. You can do it, but I personally think that using the quadratic formula is a little bit easier for this type of problem. All right, let's take a look at example 3. All right, so we're going to use the quadratic formula again. And our A is 4, our B is negative 5, and our C is 3. Okay, so then we just need to plug it into the formula. So x equals negative b, so negative 5, plus or minus the square root of b squared, so that's negative 5 quantity squared. Don't forget those parentheses if you're plugging this into the calculator, because if you don't put the parentheses there, you're going to get negative 25, but it needs to be positive, because that negative is also being squared. All right, so we have 4 times a, which is 4, times c, which is 3, and then it's all over 2a, which was 4. And now we simplify it. So x equals 5 plus or minus the square root of 25, let's see, minus 48, all over 8. So we can simplify that a little bit more. 5 plus or minus the square root of negative 23 all over 8. So that becomes 5 plus or minus I, remember pull out the I, square root of 23 all over 8. Okay, and so what I would suggest is to write this out as 2 different answers. That way we remember it is two separate answers, even though this looks like one. It's 5 plus I square root of 23 over 8, or 5 minus I square root of 23 over 8. It is easier to tell that there are 2 answers when you break it apart and write it separately. However, I will accept an answer of this. All right, now think about what does this tell you? When there's an I in the answer, what does that tell you? What is the graph going to look like? And we'll talk about that more in class. All right, let's put this into a situation. So example 4 says the volume of a rectangular jewelry box, 4 centimeters in height, is 136 cubic centimeters. If the perimeter of the base is 24 centimeters, find the dimension of the base. Okay, so first, I like pictures, so we're going to draw a picture. So we have a rectangular jewelry box. And y'all are probably better at drawing these pictures than I am, but bear with me. And so I'm going with that. All right, so there's my rectangular jewelry box. It's not a great picture. I'm not an artist. Okay, so we know that it is 4 centimeters in height. We also know that the base, which you can, if you want to, you can do that. But you know that the base, which is this part or this part, so we'll say that. And that is not a lovely picture, but that's okay. We know that the perimeter is 24 centimeters. Okay? All right. So we know that if we, let's say, this is the width and this is the length. So we know that the length, 2 of the lengths plus 2 of the widths equals 24 centimeters. We know that part. Okay, and then we know that the volume, remember that volume is length times width times height, so we know that L times W times 4, which we'll put the 4 out front, equals 136. So we have these 2 equations, and now what we can do is we can substitute. So if we solve for, let's solve for W in this equation, okay, so that gives us 2W equals 24 minus 2L, and then if we divide everything by 2, we get 12 minus L. So then we're going to take that piece and plug it in right here into our volume formula. And this is just one way to solve this problem. There are lots of different ways you could do it that are correct. And so this is just one way. All right, so 4L times 12 minus L. So now we have it all in terms of L. So we can easily solve this using one of our methods of solving, whether it's factoring or quadratic formula or completing the square. All right, so now we're going to distribute our 4L. So we get 48L minus 4L squared equals 136. Now I want to get everything over to one side. I like to keep my highest exponent positive. It just makes it a little bit easier to work with. So I'm moving everything over to the right, and I'm putting it in descending order. And then I'm just going to simplify the equation. Everything is divisible by 4, so let's divide everything by 4. So 0 divided by 4 is 0. And then this becomes L squared minus 12L plus 34. And now you can look at trying to factor it, but I'll tell you right now it's not going to factor. So let's use our quadratic formula. So we know A is 1, B is negative 12, and C is 34. I don't like the way that looks. Again, B was negative 12, and C is 34. All right, so we can plug that into our formula. So L equals negative 12, that's negative B, plus or minus square root of B squared, so negative 12 quantity squared, minus 4 times A times C, all over 2A. All right, so then we get L equals 12 plus or minus, and then that square root, the 12 squared, or negative 12 squared becomes 144 minus 136 all over 2. So L equals 12 plus or minus, and that becomes an 8 over 2. And then let's scroll a little. And that 8 can break down into a 4 and a 2, so the square root of 4 is 2. So we have 12 plus or minus 2 square root of 2 all over 2, and then we can simplify that even further. So L equals 6 plus or minus the square root of 2. Because if you divide each of these terms by 2, that becomes a 6. Here, I'll just erase that. All right, that becomes a 6, that becomes a 1, and that becomes a 1. So we get 6 plus or minus the square root of 2. So L equals 6 plus the square root of 2, and W equals 6 minus the square root of 2. And those are centimeters.